Bismillahirrahmanirrahim. We are looking at vulnerable time in carrier sense multiple access. Again, what did we define vulnerable time to be? It is the time when there is a chance for a collision happening. Okay? There is a chance that a collision can happen in this time. Now, look at this scenario here. We have station A begins transmitting at time t1. As I said before, this signal will take some time to reach B. Okay? So instead of coming to know at time t1, B will not know at time t1 that A has started. Okay? It will come to know after some time, after a short delay. Okay? A propagation delay. After some propagation delay, it will come to know at time t2 that A has begun transmitting. Similarly, for C, the signal will reach C after a short while, and at time t3 and not t1, C will come to know about A's transmission. So A started transmitting at time t1, but C does not know at time t1. C comes to know at time t3, which is there is a gap in time, and then C comes to know that there is A has been transmitting. And D in here comes to know at time t4. Okay? And D here is the farthest device from A. Okay? It is situated at the longest distance from A. Okay? So we are calling this time as the vulnerable time, or the time that it takes for a signal to reach the last device or the farthest device on the medium, the shared channel. Okay? Why is this the vulnerable time? Why is this the problem time? At this point, T2, okay, B comes to know that A is sending something. So B now will not send anything. Okay? B will not send. B will know that the medium is busy at this time. However, C and D don't know because the signal still has not come to this point. Okay? So C and D don't know that A is sending something. So there is a chance that C could send something at this point. Okay? C could send something in here because it does not know that A is sending. So if it listens to the medium, it will find it free. It will think the medium is free. Okay? But at time t3, when the A's signal reaches C, now after this, C will not send because now C knows that A has started sending something. Okay? But the last device to come to know is D. So even after C comes to know in here, okay, but even somewhere here, like really close at this point, D still does not know that A is sending. So it is possible that D can still send something, okay, and there can be still a collision happening because D still does not know that A is sending. A's signal has not reached D yet. Once A's signal reaches D, that's it. Then D will not send anything. Okay? So the time it takes for A's signal to reach the farthest device or the last device, okay, which is the propagation time, the maximum propagation time. That is, in CSMA, this is the vulnerable time. Okay, this time will be the vulnerable time because it is the time when D is not aware of A's transmission, so it could still send something and cause a collision. So we have seen the procedure for pure aloha. We have the first attempt, k is equal to 0. You send the frame, you wait for 2 TPs. If the acknowledgement is received, it is fine. If not, you go off and you increment k. You choose a random value r and you wait for a backoff time and then you send again. So this is what happened in pure aloha. But in CSMA, we don't send after the random backoff time. We don't send. We still wait. Okay? We apply here a persistence method. Okay? We apply a persistence method. Now, in the next video, we will look at the different types of persistence methods.